Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hi everyone. This video tutorial was made by Yad Al Hamada and Mohammed Bou Saleh and Abdurrahman Nasser. We are students at KFUBM, King Fahd University of Petroleum and Minerals. In this video, we will explain the basics of the Julia programming language.
Hello, I am Mohammed Bou Saleh and I'll be talking about what makes Julia a unique and powerful programming language. The first advantage of Julia is it is built for performance. Julia is designed from the ground up to be fast. It uses JIT, which is just-in-time compiler, which means that the code is compiled to machine code while the program runs. This gives Julia the speed of low-level languages like C or Fortran, which is rare for a high-level language. Secondly, it uses a clean and friendly syntax. The way you write Julia code is very similar to the way you write Python. So if you have used Python before, you will find it easy to pick up on Julia. It supports features like multiple dispatch, which allows the function to behave differently based on the types of their parameters or input. This adds both flexibility and speed. The last advantage is it is a one language for prototyping and production. In many languages, you write a quick prototype in Python, then rewrite it in C or Java for performance. With Julia, you can do both in one language. This makes development faster and more efficient, especially in research and industry. Now, just a small some questions to revise what we learned in this presentation. First of all, what is Julia and what makes it unique? Julia is a high-level, high-performance programming language for technical computing. It combines both ease of use of dynamic languages like Python with the speed of low-level programming languages like C. Features like JIT compilation, multiple dispatch, and strong support for linear algebra and numerical computing makes it stand out. Secondly, what is Julia used for? Julia is mainly used in fields that require heavy numerical and scientific computing, such as data science and data analysis, machine learning and artificial intelligence, computational biology and physics, and financial modeling and simulation, and optimization problem and operation research.
Assalamu alaikum, my name is Abdurrahman Nasser and I will continue with how to install Julia. Using Visual Studio, it's very easy. We went to the extension section and then search for Julia, then install the extension for Julia.
Now, let us learn about data abstraction in Julia. This means how we work with different types of data, like numbers, text, lists, and more.
We can access Julia documentation through the docs.julia.org and see how to properly use Julia, as we can see here. We can see the variables and how to assign the values to Julia's variables.
For example, X here is a name and the value is 10. To assign this value to the variable, we will put equal signs between them. Now, X is storing what? 10. You can use it in math like this. 10 plus 1 is equal what? 11. You can change the value of X if we put that X equal 1 plus 1 or X equal 1. It was 11, but now it is 2. You can assign a value of other types, like strings of text, like here, X equal hello world. Julia also let you use Unicode and
Now, just a small or some questions to revise what we learned in this presentation. First of all, what is Julia and what makes it unique? Julia is a high-level, high-performance programming language for technical computing. It combines both ease of use of dynamic languages like Python with the speed of low-level programming languages like C. Features like JIT compilation, multiple dispatch, and strong support for linear algebra and numerical computing makes it stand out. Secondly, what is Julia used for? Julia is mainly used in fields that require heavy numerical and scientific computing, such as data science and data analysis, machine learning and artificial intelligence, computational biology and physics, and financial modeling and simulation, and optimization problem and operation research. Third question is, why do we use Julia in machine learning? Julia offers several advantages for machine learning. We talk about high speed, which is needed for training the models and evaluation it. Secondly, it has powerful libraries like Flux.jl for deep learning and MLJ.jl for general machine learning tasks. And it has automatic differentiation, which is useful for training neural networks efficiently. Lastly, who should consider using Julia?
then it will
Julia is a great choice for
well,
researchers and academics doing simulations,
give
statistical
me the
modeling,
global
and
variable
algorithm
here.
development. Also, it is
then.
perfect for engineers and developers
Then
that
when we
build machine
try
learning
to print
or
y,
data-intensive systems.
it will give us
It is
error.
also
Why?
good for
Because
Python
it
or
is
MATLAB users who need
local
to
variable
combine
here.
both the simplicity
So
with
the
the
scope
speed
of
without
it will
sacrificing
start
one of them.
from here
And lastly, it is
and will
good for
end
anyone
here.
working in high-performance
In this
computing,
block,
finance,
just
or
in this
scientific
block.
research to use Julia as a choice.
Julia has basic data types, different types like integer here for whole number, so a equal 5 like we see before, float 64 for decimal number like here 3.14. We have bool which is for boolean, for true or false. We have character for single letters. We have string for text. Also, we can do a math between them. You need to convert the data. So you have integer or float. You need to convert them to integer. So it is before 3.7 here. To
Thank you so much for
to
listening. I
convert
hope this presentation was
the number
insightful.
to integer,
Assalamu alaikum wa rahmatullah.
we use int like a function, and between the brackets we put the float number. It will give us 3. The same thing here with the float. It will get a number in integers and will give a float number. We can use another function, which is this. So you give it the number as string, and it will give you the number as integer. We select what type we need. The same as here. When we need to convert the decimal number to, or the string as decimal number, or decimal number as string, we need to return the real value from the string. We just put the function and the type that we need and the string of this decimal number, and it will give us 3.14 as float number. In Julia, there are many ways to have a list. The first way is array. When you need to make array, you put the variable and the cosines and the square brackets. In the array, when you ask about the index of the number in or the element in array, it will handle it by beginning with 1, not 0. So this is 1, this is 2, this is the third index. Not as many language, you will have here index 0, index 1, index 2. Okay, I need to bash or add new element to the array. I can use bash here and put the name of the array and what the element you need to add. We have also table, a fixed group of values, but here it will start with as before, it will give you Ali when you give this index 2. The third way is named table. If you need something like dictionary, but it is table, not dictionary, you need to you will have many names, many variables, and you need the value of the variable. You can get it by using the name of the name table and the name of the variable of the value. So it will let you get the value of this variable. We have dictionary. It is same as the name table, and the last one is set. The best thing here it will not repeat the value. So when you give it two times, it will show it just one time. In Julia, we use if and else to make decision in our code. This are called conditional statements. So here in this block, Julia check the condition from top to the bottom and runs the first block that is true if this x greater than 10 is true, it will run this code. We always end the if block with AND. So here is the end of if block. So now x equal 5. If 5 greater than 10, this is false, so it will not run this. Else if 5 equal 10, it is false, it will not run this. Else if this not true and this not true, else run this, so it will run this. X is less than 5. Here you can also use logical expressions like and or not. So here x equals 7. If x more than 5, 7 more than 5, and x less than 10, and 7 is more than 5 and less than 10, and this expression means and. So in and we need this to be true and this part to be true. So if they all trues, we will run this line. If it is not, it will not run this time, this line. If we use or here in the place of and, it will see if this true or this true. It will run the line in the block. If it is not, it is if we put not here, this means is x is not greater than 5, and that's it here. Now if we go to for, in Julia we have many ways to make a repetition at loop statements. One of them is for loops. So here I will be in the first time 1, then it will be 2, and it will be 3 until it will be 5. It will run this code until it reach the last one here. Now while it will keeps running as long as the condition is true. If the condition get false, it will stop the running. Now we have recursion. That means a function will call itself. So here factorial, when this statement is false, it will go to else. So here will multiply n by the result of factorial. This factorial will call itself, will call this function again. So the new value will be n minus 1, like here it is 5. So when it is here, it will not run this one, it will run else. So it will be factorial 4, not 5. And always we include the best case to stop the recursion. if we don't have base case, it will run forever.
Moving on to the next paradigm in Julia, we have the functional programming paradigm. And we can test three main attributes of this function, this paradigm. We will see the higher order function and the first class function. And later we will see some lazy evaluation example. So simple example here is the map function. Here we are passing a squaring function as a parameter. And a more clear example, we have the apply function to x, where we take a function and a number, and we apply this function to this number. I define two functions, add, which adds 2, and double, which multiplies by 2. And here, if we try to execute this code, at first we will see the array after applying the squaring function to it. And then we'll see our number, which is 7. And since we passed doubled, it doubled it. If we try to add, we will have the 9 as 7 plus 2 is 9. And this is how Julia uses a higher order and first class function. For the lazy evaluation part, I have this simple program. In this program, I try to add 1 plus every single number up to 1000, as you can see in here. And I will time this program. If we run it, we'll see that it takes 0 seconds since it done no evaluation, because lazy evaluation only does evaluation when you need the results. And here we don't store any of the results, we just do them. So Julia does not do any of this, any of this operations, because there is no result needed to be stored or used in any way. So we took 0 seconds for this program. And this is the functional paradigm in Julia. Moving on to the next and the most important features of Julia. Beside its simple syntax, we have the fast decoding is done. Julia uses a library called LLVM to apply JIT, or just-in-time compiler. This helps Julia translate or compile the code from higher order to machine language during runtime or execution. This makes the program work very fast. So here we have an example. I am timing the adding operation of all the numbers from 1 up to 10 to the power 7. And if we try to execute this program, we will see that Julia done all this calculation in almost 1.5 seconds. And this is the result. So this shows how strong and high performance Julia is. Lastly, I would like to test your understanding of this presentation with a simple quiz. It's only five questions quiz, and this will take no time. So starting with the first question, what type of compilation does Julia use? We talked about it's really fast, and we said that it's about the compilation method it uses. So is it ahead of time, or just in time, or interpreter, or none of the above? Just 5 seconds to think about it. And the correct answer is just in time. The second question is, which paradigm is not supported by Julia? Procedural, functional, class-based object-oriented, or meta-programming? 5, 4, 3, 2, 1. We say that Julia does support object-oriented programming, but not using classes. We use structures and multiple dispatch. About that, how do you define an object in Julia? Do you use class or struct or object or type? 5, 4, 3, 2, 1. The keyword is struct. Fourth question is, what library does Julia use for high performance just-in-time compilation? I mentioned it, and the features of Julia. Is it LLVM or Coda or Python or OpenCL? 5, 4, 3, 2, 1. The right answer is LLVM. Last question is, what does the map function do in Julia? This is a simple one. Does it iterate over elements, or applies a function to each element, or combines two lists, or none of the above? 5, 4, 3, 2, 1. And it applies a function to each element. And we said this is one of the functional paradigm features, which is higher order and first class functions. Thank you so much for listening to me, and hope this presentation was insightful. And Assalamu alaikum wa rahmatullahi wa barakatuh.